Hello explorers and welcome to another video. Today I'm going to talk a little bit about how to set up an SSL certificate for your Docker image. So if you have an environment where you build things locally and you want to use SSL or TLS in order to get a secure environment so you can test specific features. For instance, Chrome will not turn on Service Worker if you not have SSL enabled. So if you want to try out specific features and you want to do that locally, you need to actually get SSL and trusted certificate to work. One of my colleagues had some difficulty in getting this set up, so I thought it would be informative to actually make a video so you can take what we found out together and run with it, so you don't have to have this problem that we had. And we found a lot of people online also giving wrong or misleading information. So I hope that this will help you out when you are trying to set this up. So first off, you have my little readme here where I have all my commands. I will come back to this when I need to run different commands, and this will explain everything that you need to do. So if you find this repository later, you can read up here and get what you need, and you can also ask me questions if you like. First off, we need to create a root certificate. So this is for our root certificate authority that needs a key. So we will need to set that up. So first off, we use OpenSSL to generate a key, and OpenSSL is available in most Unix or Linux installations. There are LibreSSL as well, but I don't know how to use it. So if you're using that instead, you might need another setup. So here we generate our keys and we get an output to this key here, and it should be 2048 bits. And then I create a request for this key and put in nodes key, and here we have our little key, and then it should have a message authentication of SHA-256. It should be valid for 1024 days, so a long time. And we also have this output of the actual key or the actual certificate. So this will create a certificate for us, a root certificate, and that we will use later on to install in our browser. So let's go into etc here. We will create our root certificate, start off, and here we need to answer a few questions. What country are you from? I'm from hot Sweden today. And then we need a state, let's say Disney land perhaps, and a city. I live near Gothenburg, so let's say that. And then we have an organization, my fluffy stitchery, let's say that, and an organization unit, and that's not applicable. Common name, server, common name, or your name. Well, I'm Daniel, so let's put that in there. Email address is of course testedexample.com. And there we have my root certificate. So now I have created that certificate. So let's go into our browser here, and on the settings page, in this case I'm using Firefox, but any browser will probably have this. So if you go into something like security and privacy, and then you find this view certificates, or some way you find certificates in your browser, and you usually have something like root authorities or something like that. And here you can see everything that your browser trusts today. So this is a long and jarring list, and if you find anything in here that you don't trust at all, you can actually remove it if you like. So this is to every site that you go to that have SSL. If they are signed by any of these authorities, the browser will actually think that they are trusted. So if you find an authority here that you don't trust, but now we want to add our own, so we go in here. I have my GitHub and my Apache project here, and in my etc I have my root certificate. So I add that in there, and I get this little question here. I want to trust this certificate authority to identify websites. I need to check that box, and then I'm done in the browser. So we can go back to our little editor here, and next up we need to create our website certificate. So if we go in and look at this, I have some things up here that actually checks that I have supplied a subdomain for my little server. I also need to check that we actually created the root certificate, and I also need a file v3 extensions that I will come to later. We can look at that. And then I do some setup here. I add the domain and the common name. Then I put the common name into the subject here. So this is the certificate subject for our certificate. So here we have the country, the state, the organization. I don't know what L stands for. Could that be the city? I don't know really. It's not that important. You need to put the common name down here, and the common name need to be the server URL. So that's why I actually take the common name that we get in and put there. And then I also need to replace the domain inside of the v3 to the common name as well. And I also have this secure configuration. This is a secure configuration for Apache. I also need to change the domain variable there to my common name. When we are going to create our little key here, I first off create a request. And that's the request you usually send to a certificate authority to get signed. But in our case, we will use our own, so we will sign it later. So first off, we create this request. It's a new, and we create a new key, and it should be 248 bits. It should have a message authority, message authentication code used by SHA 256. We create nodes again. We have a key out, so this is our server key here, and we put in the subject we talked about, and then we put out our certificate request. So this is what we send to the actual certificate authority. But as we are the certificate authority, we will sign this key here, and this is the actual standard for certificates. So X509 is the certificate standard, and this is telling us that we will create a new certificate here, and we take a request in, and this is the server request that we got. We say that we have our root CA certificate here, and we also have the key for that certificate, and then we create a serial number for this key from the CA, and then we do an output to our root certificate, or our server certificate, the new one, and it will be for 999 days, so it's a long time for that as well. And we will use SHA 256 for our little sign. This is actually to check that we actually have the same certificate. So the 256 is the you create a MAC, so that's a message authentication code, and that is for the full certificate, and that is what you signed later on. So this is how strong the actual binding of all the data inside of your certificate will be. And then we use this extension file that we created earlier. So let's look at that extension file. And here we say that we want an authority key identifier, and we will identify by the key ID and the issuer. So this is just to say what will identify our certificate. We also say that we have some constraints here, that this is not a certificate authority, and that's important to tell, to bake into your certificate, or else you will get some failures. And then we will tell what key usage we will have for this key. We will use it for digital signatures, we will use it for non-reputation, key encipherment, and data encipherment. And key encipherment, that's for the envelope. So if you have an SSL envelope with where you're going and so on, and you want to sign that, you have key encipherment. And if you want to encrypt your data, that's data encipherment. And this non-reputation, I don't really know how to actually understand this. I will read from the web page now where they tell about this, and see if you can figure out what this does. Use when a public key is used to verify digital signatures used to provide a non-reputation service. A non-reputation protects against the signing entity falsely denying some action, excluding certificate or CLR signing. I don't know, but your certificate should have that capability as well. And then we put in some subject alt names, and these are very important for Chrome specifically, because if you don't have a subject alt name that is your domain DNS name for your domain, then Chrome will not allow that certificate. So this is something that is very important to get right, and it took us a long time to get this actually working. And let's create our certificate here. So we create domain certificate for my server local. And there it created my little certificate. So let's look at the configuration for my Apache server now. So here, first off, in my secure configuration, I need to turn on SSL and rewrite. Those are two things that are good to actually have. In the image I'm running at the moment, my Apache will not, in the SSL module, will not support SSL compression. But if your image does that, then you want to turn that off, because there is actually fault in the thought about how to use this. So if you're using SSL compression, you might have degraded security, because there is a man-in-the-middle attack to this compression. So you should not have that turned off. That might change in the future. These things usually do. And then you want to honor the cipher order. So this is for the cipher suits. So I wanted to check for these in order. So the first, if we can use that, and if the server, the client has that capability, I want to use that first, and so on. And then I want to have all the SSL protocols, but I don't want to use SSL version 2, because that is not that secure, probably deprecated. I don't want to use SSL version 3. I don't think SSL version 1 even exists anymore. I don't want to use TLS version 1 or TLS version 1.1. The current one is TLS version 1.2, and I think TLS version 1.3 is in the making, but TLS 1.2 is really old. So it should be fine. Everybody should have it. All browsers should support it. So I wanted to turn off all the old, less secure versions of TLS. And then the cipher suit here, it's a lot of them, because you want to support older browsers as well. But if you want to read one of these, then you first off have Diffie-Hellman key exchange. So this is an elliptic curve Diffie-Hellman key exchange. So this is how you exchange keys between each other. And then you have the authentication. So you actually check that you are the right parties. That is also in elliptic curve DSA. So that's the key that you use to actually authenticate yourselves. And then you use AES-256 with GCM. So AES is an encryption algorithm, and GCM is actually a interesting addition that makes it possible for you to send unencrypted data but still have it signed on the line. So this is a very common encryption algorithm to use for the data, sending the data, and then you use SHA 384 bytes for the message authentication code. To validate that your message is still the same that the sender actually sent. And then we just turn on strict mode for this, and we listen on 443. And then here you see where I changed the domain name. So this is to set the actual server name of my server. And then I create a virtual host. So this is standard Apache configuration. Turn on SSL. I say where my keys are, and then I set on strict transport security and how long it should actually be valid. And this is to say that this should always run over TLS. You should never run over anything else. And if you have ever found a correct certificate, then you should not be okay with going with a less secure domain. So if you find anything that goes over HTTP, you should automatically push it over to HTTPS, and that's something that the browser does. So that's that. The last thing we want to look at is the Docker image. I use an Apache HTTPD Alpine Docker image, and Alpine is this amazing little Docker image server that is actually only 5 megs. So with the HTTP server, this is 70 megs. So the large part is actually Apache in this case. Then I copy over my public directory here to the docs, so I actually get my indexed HTML sent over. So this is where you will put all your data if you are creating a web site. I copy over the server keys. I copy over this secure configuration for Apache. And then I add this line to my Apache HTTP configuration that will include my secure configuration. So it will actually extend the Apache configuration with my configuration. So let's go down here and we go back to my little README, and I do Docker build. You might not need to do sudo. I do for some reason in my setup here, because it doesn't really allow me to build images otherwise. Your mileage may vary. So that's how we build this. It's quite fast to actually build it. Now I really pulled down all the data as well. I haven't built it before. And then just set it up and got it running. And then we have this little phrase here to run this as a daemon interactive and with a terminal, but I haven't specified any command, so it will actually not turn it up. And I put a name in here, and I want it to run on 8443, and then 443 in the back end, and my server image. So let's start that up. Then I need to go in and actually see here if I can find slash. There we have it. We need to go into my host file as well, and on localhost here I want to add my server.local in order for it to and I need to be sudo to do that. Let's see, can I please get to edit here? My server.local. So it knows that my server.local is actually this server and nothing else. So we go back here, we have my server local, see if it actually goes to the right place. If we do 443 here. Bad request. Your browser has sent the request to the server. Could not understand. You're shaking a plain HTTP for an SSL enabled. Well, that's good information. We need to put SSL as well. And ta-da! We did it. Now we have a secure certificate tunnel here with which is verified by My Fluffy Stitchery. So this is how you set up your own SSL certificates, how you create your root certificate and then create your host certificate, how you edit your Apache configuration in order to use your certificate, and also which different cipher suits you should use. I haven't gone through them all, but I have copy-pasted into this repo some cipher suits that are recommended today by SSL Labs, and if you watch this in the future, they might not be that secure, so you might need to look at some new ones. But it's a good thing to actually keep on touch on these and update these, not regularly, but sometimes, because security is a changing field. So what's secure today will not be secure tomorrow. I hope that you found this video interesting. I hope that you learned something today. If you like this video, give it a like, share it with your friends and colleagues. If you have any comments or questions, leave them in the comment section below. And I really hope to see you in the next video.